こんにちは。Yeah. Oh, no, you took a break? Yeah, every day. For a little bit. This is the unit third one. Because we have another quiz. To break it up. Yeah. That's right. They were. Oh, maybe begin. Timer has not began yet. The timer has not. Someone understand. Ah, okay. It's hard to tell the difference when it's on and off. Other people's time. Again.
No.
Yes.
I thought we were gonna have it like in public letters and after we read
Whatever.
Oh, and okay. The last weekend. Okay. I had the best one. I have like nice.
Yeah.
That's the favorite, really.
Okay.
Like each time's gonna quiz.
It's at the end of class, but it's online. So you could take it home. Hello. Nola, you have a cross country meet today?
Yeah.
Is it at Pierce College?
No, it's at Mountain Staff.
Okay.
Like I did. I'm we're ready.
It's purely for your own information. Don't worry about the time.
He's like Rohan. He's like.
Have a seat before you're late, guys. We're gonna do the unit circle quiz at the beginning. Double quiz, yeah. Today's like a quiz sandwich kind of day. We'll start with unit quiz, end with the quiz.
Wait, you say unit for like
That is fun. Two quizzes, one beginning, one at end. Oh, wherever you want. I recommend degrees and radians inside, coordinates on the outside, but whatever you feel most comfortable with. If you want to draw the triangles, you're always welcome to do that first for your reference. It's completely up to you. Are we missing a bunch of people today? With traffic or something? Or should they get scared? I don't know. Anyway, let's not be stopped by that. Uh, 3, 2, 1.
Working your time is optional. Who's this person? Andrea, got it. Yeah, man, they're gonna start popping in soon. You go first. I'm probably that. Who wants to first? Sorry. Who wants to back? I'll take it.
Are you done? You have to draw the picture of your favorite superhero on the back. Or
minutes at best at this point in the future. I would like to basically looking. Take just a moment to, I think we've done this before, but just check in, maybe you could get your parting from tips or figure out what you, share what you. Your thought process in making this happen quickly.
And you're in either circle quiz or not. If you could all practice the one person in your class to keep going. Because your quiz is up, and give it to one person in your class, they're nice, what do you think? Next up, please.
What speed do I need you to get to?
Is it important? Any particular speed? 3 would be great, 4 would be great. If you can't do it in under 5, eventually, I'm a little bit concerned, but really what I want you to be able to do is visualize it. And at will recall anywhere, if I ask you any place on a unit circle, to be able to recall those coordinates in a matter of 2 or 3 seconds, or maybe 1 second. If I say 4 pi over 3, I want you to be able to think, I know that. If I say negative pi over 6, I need to be able to think, I know that. Because you know unit circle, I just want to be familiar with it and be able to recall it. The whole point of this is just so you don't have to think too much when those questions come at you. I mean, they will come at you. And I want it to be a pleasant experience. Speaking of pleasant experiences, shall we do some new stuff? I need the last 20 minutes for a quiz. The official quiz, not the unit circle quiz. Very often we're going to see a set of 4 problems like this. You know, I'm going to refer to these. Notice they're not numbered. I'll refer to them as quadrant number 1, 2, 3, and 4. We're going to start with quadrant 1. So it tells us that sine of theta is equal to 2/3 in quadrant 1. Find the value of all trigonometric functions at theta. So step 1, I'm going to just kind of make a list. Sine of theta is equal to 2/3. Cosine of theta equals something. Tangent theta equals something. Cosecant theta equals, you know, 3/2 right there, reciprocal. 1 over 2/3, 3/2. Secant of theta is equal to something, and cotangent of theta is equal to something else. How am I going to figure out the other 4? Where's math? We're going to have to draw the triangle. This is trigonometry. Let's draw the triangle. Notice that 2/3 is not a place that we're familiar with on the unit circle, so it's not quite easy to come up with the other values. So the triangle, it says it's in quadrant 1. I'll put that like right there. So the angle is right here, and I can just drop it down to the x-axis. What do I know about this triangle? It's a right triangle. Anything else? We know 2 and 3. 2 is the opposite. 3 is adjacent. So go ahead and finish this off.
No.
Oh, 3 is a hypotenuse. Excuse me. Oh, it's a sign, thank you, 2, 3. Good catch.
Are you ready? Ready? Ready or not? Let's see what you got. Miles, can you help me out with this one, please? Oh, yes. Thank you. All of them, but like. All of them.
Okay.
Well, just quadrant 1, but yeah,
Yeah,
these 4.
So cosine of theta is 5.
Where did you get the root 5?
And I did the.
Do we agree?
Yeah, I agree.
Thank you. Okay. Sorry to interrupt you. Yeah. So root 5. Okay, so you said root 5 over 3.
5 over 3.
Okay.
And then CK is the slope of that.
Oh, okay. So that means
3 over 5.
we just leave it like that?
Yes.
Yeah.
Yeah.
For any radicals like that, unless otherwise noted. Any, always leave radical.
Opposite over the is of 2 over root 5.
2 over root 5. Cool.
It's so nice to just have that radical on the bottom, just bring it to the top like that. Satisfying. Yes. So unless it's obvious, I would simplify that. Correct. You've been leaving it rational and radical and object. It says simplify. I think it just likes you more. Okay. I need to be able to take meaning from this. I want you to read this up on your brain, not out loud. Discuss today what does it mean, right? Can you please show me the number that you should be thinking of when you see that expression right there that I've underlined? The number that you think of. Quadrant 2, right? That's saying it's between pi over 2 and pi. It's just not saying we have an angle in quadrant 2. So we're doing this problem. After you set it up, you're going to put your angle in
Quadrant 2. How do we get the triangle though?
We need a triangle. Thank you. Did you hear him? There's only one correct way to do this. Drop it down. Do not go to the y-axis to make the triangle. You can see that somebody might try to do that to go to the y-axis. Please
Don't. We're always talking about x and y coordinates, so drop the angle down here and completes the exercise from that. So go ahead and finish this problem, please.
We'll be calling someone in about 14 and a half seconds. Great. And that happened. Okay. Chazzy, can you help me out with this one, please? Wait, how did you get, do you go directly to sign?
And from this information?
Oh, well, no, so it's like that, that's not, but then the high quality.
Wait, but I don't know anything yet. It's empty. Help me fill that in, please.
Triangle or the.
Yeah, there's no information. You're talking about the link by findings, but there's nothing else.
Oh, okay, yeah, so you can.
I need help.
you can-
Jazzy, help me. Yeah.
You know that you can update and negative two,
Okay,
then you can send that. Bottom,
Okay.
I found it here.
does he speak the truth? Are we okay with this? Okay, nice.
And you can say fine.
Did you go directly to sign or did you do something else first? Just out of curiosity. So they could one have, but then you, but I guess once you have the triangle, it doesn't really matter, does it?
And then root through the plan.
Okay, excuse me, good.
And would be, negative.
Okay,
Would be gonna be two.
is it okay to leave that one over root 3? Is that okay? Yeah, that's fine. I don't care. You can rationalize it if you want. Nicely done. Thank you. Do you notice anything? It's on the universal. We know data, don't we? What is data? Check finally with the data. What is data? On the count of 3, let's hear what theta is. 1, 2, 3. There we go with that. The second quadrant. Oh,
negative.
120 or. So we should say 120 degrees, right? So that people don't think we're talking about radians. 120 degrees or.
Yeah, what?
2, 5, or 3 radians, yes, is that correct? Maybe one, I'm on 32.
Which one is it? So, you know,
That's a great question. Anytime you see it, by the way, this isn't asking for data, it's not asking for us to find it, it's bonus if you find it. But when it's represented there, it's a standard angle, which means we have to come from, where's the initial side? So like, come from here and then go. Yeah, so our theta, and Chazzy, I'm so happy you brought this up. This is our theta, which is impossible to do SOHCAHTOA in, isn't it? But we're talking about the other angle, this angle right here, which we call the reference angle. So this is a reference angle right here, and that's denoted by theta prime. That's a little apostrophe there. So reference angle. Theta prime. In the first problem, did we need a reference angle? We did not. So here we needed a reference angle just to put everything together. Now, if you put theta here, then everything should be positive. Right? So theta is in this angle, which doesn't make any sense. There's still 2 more problems to try. Don't get in the way. a glance at your partner, just make sure that they're at least in the right quadrant for the problems they're working on. Did they draw anything?
From. No, can you help me out with tangent of theta equals 2/3 with this one, please? I'm sorry, I'd like to hear Nola, so I need, I understand you guys are discussing the problem, but. Hold on. Go ahead. Oh, okay. So we have 2/3, so yeah, we don't need anything for that, do we? Cosine is. And did you make a triangle? So what did you say cosine is?
Okay, how do you know that?
Well, it says cosine of theta has to be less than, okay, so. Oh, yeah, be careful about this. Last time we
Talked about the quotient identity that says tangent of theta is equal to sine of theta over cosine theta. So it's a very common error. You say, well, I know this is true, so sine theta is 2 and cosine theta is 3. Not only are we in the third quadrant, but this doesn't equal sine. This is a ratio to quantity. So this doesn't necessarily to the top of the graph.
This, sorry, this doesn't. You have to think about this, though. You need a triangle. You know what a triangle? Yeah, you said it's quadrant 3, right? Okay, so I'm gonna go ahead and start making this triangle in quadrant 3. And what do I know about this triangle? Yeah, it tells us that tangent of theta is equal to
2/3. Do you see how I'm gonna write that in this angle, in the triangle? Let's think SOHCAHTOA. Tangent's equal to what over what? Adjacent, opposite over adjacent. So we're gonna go to our reference angle right here. And then opposite from that is, so 2 and 3, are we okay with that? It would be okay if it's first quadrant, but we have to label these both negative, don't we? -2 and -3. So Noah, what's the hypotenuse here?
all this h, it's like 8 squared is equal to 2 squared plus 3 squared. I'm gonna ignore those negatives because it's negative. 8 squared is equal to 4 plus 9. 13. So the hypotenuse is square root of 13. Any questions? Oh, should it be positive 13 or negative?
Square root of 13. Hypotenuse, always positive. Always, it's never a question. And there's no directional component. It's only x's and y's would be positive / negative. Hypotenuse is positive. Okay, so now that we have our triangle, Noah, do you see what the sine of theta is going to be? Say it again. Over. Look at the triangle. Square root of 13. Okay. Were you going back to your old answer? Ah. So cosine of theta? Over rad 13. Now notice. If I put sine theta over cosine theta, I get my 2/3. But this is definitely not sine and this is definitely not cosine. Please be careful. Okay, and let's finish this off, Noah.
And any questions? Reminder, when
I say check in with your partner when you are done or stuck. I expect that to happen. Understand?
yeah, this one, you know, work with it a little bit. It doesn't tell us any of them, but it does
Tell us a point. Okay, so let's make the angle. Angle from that, we'll draw the triangle. Yeah, exactly. So we have 2 over here, -1 here. We have a point here. What's the point of that? To create the triangle. We know that every angle starts with what side? Every every angle starts with, in standard position, starts here, doesn't it? So it starts here. The question is, where does it end? So you imagine your terminal angle is going through this tells you very definitely it's the end like through that point. But we have to make a triangle from there. So how do we do it? Yes, Hudson? It's the truth. We could also choose like 4, -2, and 20, -10, but why do that? Let's use the point that they give us. All right, so, let's do this. Let's do this one. Who could help with this? Yes, Rihanna. Can you help me out with the triangle first?
Okay. So it's that is two.
So this right here is 2.
That's two.
Oh, okay. Do you know the other leg?
Oh, you had other one.
Thank you. And the hypotenuse?
One thing. It would be the same size.
Thank you. Okay. Then from there,
Sign and then you want to go to the third side.
okay.
And then the third side is you on the third side. And then you know that sometimes it would be one of the ones. Once you do this, it would be the third side. This one would be the third side of the third. And then the
Any questions? Chazzy, that's a good question. I was just gonna ask. Yeah, Rihanna, you said you didn't use the triangle. What'd you do? Oh, did it wrong?
The one for one.
Uh.
I like visualize, I didn't draw the triangle, but I visualized triangle and I just threw a tangent and just like know the size.
So you, if it's tangent, then you know the sides. Oh, I like that. Okay.
It just that's why I did that one.
Okay. There are other options. Thank you. There are other options. You don't have to use a triangle. Like, this last one goes about tangent. You may remember from last time we talked about a Pythagorean identity. Tangent theta plus 1 is equal to secant squared theta. From there, you could plug in your tangent theta. I hate doing it this way personally, but if you really love to use equations, well, the problem is here. When you solve for sequence with a big, let's use the positive or negative, you know, you have to positive anyway, and positive or negative, positive, or triangle. We're getting there every time. Okay, moving on. Well, who's gonna? Wait, I can't imagine actually doing something like that. That's funny. That's really funny. Thank you. Before we do this, I'm gonna give you just like until 12:23 to zone out a little bit. Stretch if you want to. You're looking up, right? No, if you need to go, this shouldn't be every time. Standard places, but any run in the circle will have any degree, any radiant. There's sine, cosine, tangent.
Oh.
Root 5 circle.
Yeah, that like a really good. So like, you know what I mean, like. So like the proof is the limit you go.
Like if we have 1, 2, and 3, right?
Yeah.
That's not a good circle. But if we cut it down, 1, 1/2, We could force it into unit circle. With the radius. The ratio is already.
So that's why like in the first one, where our radius was. We were still able to apply it.
Yeah, it's very much in the short of that area, you would look at why.
So if it was like, if it was like a radius.
That's why we're the street, man.
The points still be the same, it's just like, they would be the same, like, with that line.
If we scaled up, yeah. The coordinates. Okay, I'm gonna go ahead and start again. And for those who weren't listening to the conversation that Andrew, I just had, I think it's really important. Let's remember what the unit circle is for. It's a tool. It's just a tool to get the sine and cosine very easily of all those points that you've memorized. But you've used triangles. Right? Like we're doing here, you don't need to have a radius one. Unit circle is just to have quick access to sine and cosine, and from that, tangent, cosecant, cotangent. But it's not always that helpful, and it's not always applicable. Like the only one we could have used unit circle for was if you noticed this one. So triangles will also be your gateway to these concepts that we're getting.
And so could Joa, if you're. Okay, before we talk about
This, I want to talk just generally about functions. Imagine a function, if you will, y equals f of x. Can you visualize this function?
Yeah.
Really?
No.
No clue. All we know is that it passes what test? The vertical line test, because it's a function. Now, let's say we take this nebulous function and we do the following to it. First, I'm going to do this. Don't call out what happens. Also, I'm going to do this 2 times f of x. Also, I'm going to do this f of negative x. And lastly, I'm going to do this. Would you please discuss with your partner what effect will doing these adjustments have on the original function? So, Okay. If I can get your attention. First of all, there's something interesting. It's something that I labeled, like it's read my. It's almost. But in gestures. In general, we have things that happen inside the function, outside the function. Inside it affects the y. Inside the x is outside the function, y. So in gestures, please show me that there's 2x. Inside goes horizontal, right? Take it and compressing it specifically by a factor of 1/2 that reciprocal. And remember that right in the middle of that compression is the y-axis. Two is on the outside here. Please show me adjustments what this will do to the function graph. Yeah, it's a strong. A vertical stretch by a factor of 2. When it's outside, it's intuitive. In fact, counting here that there's 2x smooshes together. And so this is a 2 f of x is a vertical stretch by a factor of 2. And of course, right in the middle of that stretch is the x-axis. Please show adjustment negative x. Negative x the reflection over y, and the other one. Okay, we have to put this in mind today because you have two new, maybe it's already done it. New parent functions. Excited? That's what I'm talking about. Are you excited?
Yeah.
I can't hear you.
Yeah.
So sad. Okay. So we're gonna graph f of x equals sine of x for at least one period, labeling 5 critical points on the graph. Okay. Y equals sine of x. Things are gonna change a little bit. If you already have experience with this, awesome. Just be patient with the rest of us. I'm going to refer, of course, to the one and only unit circle. Now, just to set this up correctly, I'm not gonna make like a even 10 in each direction axis. I'm gonna make this longer in the x direction, and I'm gonna go all the way to 2 pi. Let's split this into how many pieces?
Those are our 4 quadrants. So cut it in half, it's pi, and again, pi over 2, and that is pi over 2. And there's other ones, there's 5 or 4 in there, but I'm not looking at it. Now, let's track the sine value. If you would, after you could have drawn what. Sine has to go from 0. Here, sine is equal to what? Other 0, isn't it? Sine is equal to 0, right? Here, it's equal to 1. So on my graph, I'm going to start at 0.
And end at, is it gonna go higher than 1?
No.
No, okay, so it's gonna start here and end here. Do you think it goes up in a straight line? It is a curve, it's not linear relationship, something like that. And then for the next quadrant, tracking that sine is gonna go from 1 and go down to 0. Now, when I say the next quadrant, does it make sense that I'm gonna graph that? But this is the next quadrant, the values right here. We're going from pi over 2 to pi, in that quadrant 2.
Sine goes to 0. Take it 1 and then back up to 0. So it looks like I need to have negative 1 down there. There, so I have this nice curve. Something like this. Does it stop there? It keeps going. How far does it keep going?
Does it keep going up? It's gonna repeat that pattern, isn't it? Because that's one period of it. So we continue like this, and does it start at 0? We have negative angles? Yeah, negative angles. So there are values here that would do something like this. So this is a parent function. That 0 to 2 pi is a parent function. And we're going to be using that a lot in this class. Something to look forward to. Yeah? Let's do y equals cosine of x. So we're still using unit circle. We're going to set this up the same way. Maybe I can make my x-axis a little bit more horizontal. That looks better. 2 pi. Going to cut that into 4s. So in this case, what's happening with cosine? Where are you doing cosine? If you get 1 going, 1, 2.
Start up here and go to 0 to make a line. The curve just like the other one like that. So as we continue, like at pi, what is the value of cosine? It is -1. Then it comes back up to 0. It's definitely not 5 or 6. That's a 2. Thank you for helping me with that legibility. Each one of these has 5 points I need you to pay attention to anytime you graph these functions. Does that make sense that each one has 5 points? Like the first one is right here. You see where the other ones are? The peak, middle, low, right there. And for cosine, these are the 5 points. I recommend plotting those points first, and then kind of I'm not getting skeleton do drawing. I do want to warn you that there are some common deductions. If I see something like this,
Right, let me do it in black. I hope it makes sense that I'm gonna deduct a point if I see that. Right? Right. Right. It doesn't get higher than 1. And that the peak should be the peak. Don't go up from there. And also I will take off points if I see something like this. Yeah, it's common too. I know. Just don't let that be you. I want you to have full points. And definitely taking out points if you do something crazy like this. It's a curve, but it's the wrong direction. You have to be like, oh, I'm at the top of the hill. They're gonna have a slow roll down. There we go. Okay, that's cosine. And you know, I'm a big gesture guy. I like you to be able to show me your turn function. So, like, you have your pocket parabola today? Yeah. Okay, you brought it. Good. Nice. Happy to see. I also want you to be able to show me sine. Sine, you need to show me 2 different hands. Yeah, that's fine. I don't care which way you do this, but this is sine. Just one period. And for cosine, the gesture I normally use is difficult to do with 2 hands. It's this for one cosine. But you're right, they have the same wave. But for a cosine wave, does it make sense that I would say this, even though this is exactly what I told you not to draw? I just would have to break my finger in order to make it curved. I'm not willing to go that far. But just imagine this is a cosine wave. So if I ask for what is cosine looks like, I'm gonna do this, sine, do something like this. Okay. Let's try a problem. Let's start with quadrant 3. Would you please discuss with your neighbor? Please discuss with your neighbor. What does this 5 do to our sine function? What does that 1/2 do to our sine function? Run swiftly, Bowen. Okay. Okay, that's 5. You please show me what it's gonna do to your sine. Show me. In this case, I think we're on this side. It's not gonna do this. It's a by factor of 1/5. So what's that gonna change with your sine rate? The period is gonna go from 2 pi to 2 pi over 5. Yeah, that period is going to change the 2 pi. Oops, that's a 225. 2 pi times that 1/5 or 2 pi over 5. So when you're going to graph it, where should that 2 pi over 5 be? Yeah. Don't make it too small. Let's make this 2 pi over 5. How many pieces am I going to cut this into? 4. Why 4? 4 quadrants. First thing you do is cut it in half, then cut it in half again. I can help you label this just because we're kind of running out of time. That middle tick mark is pi over 5. Half of 2 pi over 5 is pi over 5. And half of that? Nice. Half of pi over 5 is pi over 10. And we can use that to count up pi over 10, 2 pi over 10, 3 pi over 10, etc. And that 1/2, what does that change about the assignment? The amplitude. It's no longer 1 to -1, it's 1/2, -1/2 to 1/2. Where should I make that 1/2 and -1/2? Pretty close to the axis? No. Now open it up a little bit. You don't have to be like, oh, 1/2 is small. It's all relative. 5 points. 5 points. I'm going to put these 1, 2, 3, 4, 5. and then just graph away. Did I do something wrong?
I over 10, I over 10. So what's the other unit that's small? On your H never. Because outside of the function, we're having that, one half, the vertical. Compressed with that type of one half. The one and negative one, that's much. Multiply by one. It normally goes one negative one. Any other questions?
I'll give you a couple minutes to maybe talk through the other ones, but we gotta get started on the quiz soon. Oh, for this one, just so you know, think of it as pi over 2x. Yeah, of course, that's fine.
Quiz, you will need your laptop. Oh, yeah, I got my It's there. Yeah. I got it.
You need a calculator. This is not gonna be on.
Oh. Which one?
First quadrant.
Two.
Oh, yeah.
You will need that.
You're calculator. You're gonna have a calculator, you may use your phone today, but please. Oh, yeah, I'll pass that. So it's on the house, sorry, it's on my math class. You'll need a password. Password is 9 letters. 9 letters. So Casella.
All caps.
Oh, all lowercase, no spaces, no dashes.
Like so Casella, all
Yeah.
Yeah.
There's timer on it.
Don't get to 20 minutes.
Give your feedback in the end. No caps. No spaces, no dashes, it's 9 characters.
says you can't. but you have to. No, so the problem looks like. Don't be back in it. If it says don't be back in it, you have to. Yeah. You're welcome to use it. Saying. But I'm process for everybody.